Okay, so in this video, we're going to finish our notes about exponents by talking about rational exponents, which means exponents that are fractions. So a rational exponent is just another way to write a root, and I'll show you where the notation comes from. So first, consider the property x squared times x to the third equals x to the fifth. We know that this is true because you add the exponents together when multiplying powers. And then separately, consider the property that the square root of x times the square root of x would give you just plain x, because it would be root of x squared, and the square root of x squared is just x. And now we're going to find a way to combine these two properties. So it stands to reason that if I was to try to write this equation, sorry about the loopy pen, with exponents instead, I'd be looking for some power to put on this x and multiply it by that same power, because these two things are obviously identical. That would give us x to the first power, right? That answer has an exponent of 1. And so if we try to figure out from the first property, there must be two identical numbers that when added together gives 1. And if you're thinking, you should realize the number we're looking for is a half, right? 1/2 plus 1/2 should give us 1. And so we've never seen a fraction used as an exponent before, but it should make sense that x to the 1/2 power times x to the 1/2 power would give us x based on the property. And now we can understand that square root of x and x to the 1/2 power are equivalent statements. So the square root of x, don't know why it is changing colors or writing so strangely. All right, let me just try to fix this. So we've got the square root of x equivalent to x to the 1/2 power, okay, because of the combination of the properties above. And now we can expand this understanding by talking about other roots, not just square roots. So if you have x to the 1/3 power, that's going to be a third root. So what this means is that the denominator of your rational exponent becomes the index of the root. Maybe you want to write that down for yourself. Okay, so the denominator becomes the index of the root. The denominator becomes the root. So if it was, you can imagine, the fourth root of x, we could write that as x to the 1/4 power. But now we got to get the numerator involved. So let's say we have a numerator other than 1, so like x to the 3/4 power. The denominator still becomes the index of the root. But now there's a power on the x, a third power on the x, which can either be written inside, and this is a perfectly acceptable simplified answer, or it's equivalent and equally valid to put the exponent on the outside. Either one of these would be acceptable. I tend to put it on the inside, but there's going to be times when you'd rather do the root first and then raise it to a power, especially if we know what x is, as in we're given a number. So if we had x to the 2/5 and we were trying to rewrite it, we would remember that the 5 becomes the radical, so fifth root, and inside we would write x squared, or you can write the squared on the outside if you prefer that notation. So evaluating some of these expressions, you may not think you could do these without a calculator. These seem really complicated. But if you are given a number as your base, it's actually really quite simple as long as you remember to do the root first. And so here's where, as I said, it may be helpful for you to think about the exponent being on the outside. So the denominator becomes the kind of root, which here is just a square root. Normally we don't show the two, but I will. And then to remember that the 5 can be written as an outside power. Why is that helpful? Because the square root of 4 I know is 2. And then raising 2 to the 5th power is not that difficult. Certainly not as hard as raising 4 to the 5th power. Similarly here we have 9 to the negative 1/2. I'll just remind you that negative powers are simply fractions. And so now I can rewrite this as 1 over the square root of 9 to the first power, which gives us 1 over 3. Fourth root here of 81, and then I'm raising that to the third power. Here's an example where it's certainly easier to do the root first and then raise it to the third power. Do not try to raise 81 to the third power and then do a root without a calculator. The fourth root of 81 is 3, and 3 to the third power is 27. And 1 is pretty easy because any root of 1 is 1. And then raising it to any power is 1. 1 is great that way. Further practice with some of our exponent rules. So just remember that when you multiply two powers together, you add their exponents. Well, the same thing is going to apply when the exponents are fractions. You just have to remember some basic rules of fractions. So when I'm trying to add fractions together, as I am here, they will need a common denominator. So I have to think about 1/2 and 2/3 as both having the denominator of 6. 1/2 is equivalent to 3/6, and 2/3 is equivalent to, let's see, if I'm changing the denominator to a 6, that means I'm multiplying by 2. So the numerator would be 4. And this would give us x to the 7/6 power. We can leave it like that, or you could write it as the 6th root of x to the 7th. Sorry about the pen. But generally, if the original question is written with rational exponents, you could write your final answer with rational exponents. You only need to change forms if you're instructed to do so, or if it helps you simplify the problem more. This is not considered more simplified, so you don't need to write it in the different form if the original question was written in rational exponent form. Now let's see if we have some, we're not going to do all of these, but just some practice problems to help us on our homework. Let's see B of here, because this is going to review what we went over in class. Okay, we've got 2 parentheses xy squared to the 3rd power. So here it's important to note that the 2 that's out front is not being affected by any of the powers. The exponent of 3 is coming into these parentheses and going on each factor. So x gets raised to the 3rd power, and y squared gets raised to the 3rd power. And there's nothing else I can do to simplify that further. For something like G, that's going to bring in the new rules that we just learned. So let's talk about -32 being raised to the -4/5 power. It's helpful to think about it as a root first. So we've got 5th root, -32, and that whole quantity is being raised to the -4th power. Well, we don't like seeing negatives under roots, but it's okay if it's an odd root. So this ends up being -2 on the inside of the parentheses. And being raised to the -4th power is like 1 over -2 to the regular 4th power. And -2 to the 4th power is 16. So this ends up being 1 over 16. And is there any other example here worth doing? The other ones you're going to have to play with. You may not be very good with something like K right from the outset, but I'll show you this one. There's a similar one on your homework. So question K says x plus y squared, and we're multiplying it. Oh, well, actually, we'll say dividing it by x plus y to the -2 power. I was already in my head simplifying. This is question K. Because I don't like negative exponents, I know I'm going to have to bring up that whole expression. So x plus y squared is getting multiplied by x plus y squared. So we bring up the whole expression and the power becomes positive. And then this is x plus y, x plus y, x plus y, x plus y, right? If I was to spell it all out, which is x plus y to the 4th power. It's not necessary to expand that all the way. It was more just an exercise in simplifying using our properties of exponents, so we can just leave the answer like that. And that is